In this example, you're asked to rearrange a given equation to put it in standard form for the equation of an ellipse. And so I've written the equation that you were given in the example here. And then here in blue is the standard form. So this is the form that we're trying to put this equation into. And actually, here, maybe I should make a small adjustment. This form that I've written in blue is if it's centered at the origin, at 0, 0. If it's centered at, let's say, hk, then I should have x minus h squared and y minus k squared, if we want to write this in the general standard form where it could be centered anywhere in the xy plane. So let's shoot for that form. So the first thing here is you want perfect squares in the standard form. You want an x minus h perfect square, y minus k perfect square. And let me get rid of this. So you want the whole thing squared. And the method for writing an expression in that form is completing the square. So the first thing I would suggest here is to move the 12y over with the y squared here. In standard form, you want a y expression squared, just a single y expression squared. So you want all the y's contained in one parenthesis. So I'm shooting for that first. Y squared minus 12y, and then the 4x squared. And now that we've subtracted the 12y, this side is 0. Okay, so I'm going to change the order. I'm going to put the x term first. So I'm just trying to get it closer and closer to this form over here. So I'm going to write 4x squared in front. Since this is addition, the order doesn't matter. And then now I'm going to think about completing the square in this second expression. So notice that the first expression is already written as a perfect square. We're going to take care of that 4 coefficient. I mean, this time it happens to be a perfect square anyway, but we're going to take care of that coefficient in a second. Y squared minus 12y. Now we're going to turn this y expression into a perfect square by adding, this magic number that's going to turn this expression right here into a perfect square. Y plus or minus something quantity squared is what we're hoping for. Okay, so we still have the 0 on one side. One thing you have to be careful about when you complete the square, whatever you add to one side, you have to add the same thing to the other side. So I like to set up my little plus blank over here. Now to figure out how much to add, I think I'm going to do that scratch work over here to the side. Now, once again, you don't have to add anything in the x expression because it's already x squared, so that looks good. To figure out how much to add here, you take the coefficient of x, or y, to the first power. So in this case, the negative 12. Divide it by 2 and square it. And so the only number that's going to change from problem to problem is this negative 12 up here. You always, oops, I wanted to change colors. You always divide by 2 and you always square it. So the only thing that's going to change is the negative 12. In this case, you divide negative 12 by 2, you get negative 6, and then you square that, you get positive 36. So that's how much we should add here and here. So now, there's a shortcut to factoring when you've completed the square. What goes here is always going to be half of this value. So in this case, I see negative 12, so this is going to be negative 6. It's also nice to think about it the long way, so the old-fashioned, not old-fashioned, but the way we've been factoring, find two numbers whose product is positive 36 and whose sum is negative 12. So negative 6 and negative 6. You multiply them, you get positive 36. You add them, and you get negative 12. So that's why we have negative 6 here. Like I said, we're going to leave the 4x squared alone for now, but we're about to do something about that. Equals 36. So one other thing about the standard form, you always have a 1 on this side for the constant. So now we want to make this constant a 1, and we'll do that by dividing by 36, which is perfectly fine as long as we divide each part of this by 36. Now we should simplify here. You can cancel a 4. There's a common factor of 4 in here. 36 divided by 4 leaves 9 in the denominator. And here the 36's will cancel, so you just have 1. And now the equation's in standard form. I'll write it on the next page. So the standard form is x squared over 36. Oh wait, no, the 36, and then we canceled with the 4, sorry, so that was 9. And then y minus 6 quantity squared, that was over 36, okay, equals 1. So now you've got an ellipse centered at, so if you think of this as x minus h right here, then the h is 0. So the x coordinate for the center is 0. And if you look at this as y minus k, then k is 6. It's always the opposite sign. So I see minus 6. This thing is centered at 0, comma, positive 6. So I just go 1, 2, 3, 4, 5, 6. I've sketched a little grid here. All right, there's the center. So when you graph the ellipse, you should graph the center first, and I've gotten a bit ahead of myself. So here's the standard form. That's the answer to the first part of the question. And then the second part was to graph it. And so I plotted the center. That's the first thing you should do. And then you go out so many units to the left, so many units to the right, and that depends on this number. So that's what I'll do for step 2, is plot points 3 units, since this is 3 squared, 3 to left and right. So we could do that now if I just count 1, 2, 3 spaces to the right, 2, 3. I'll copy a grid in next time I make one of these videos. And then last step here comes from the 36 in the denominator here. So since that's 6 squared, you're going to plot points 6 units up and down from the center. So 1, 2, 3, 4, 5, 6. So this would be at 12, right? Because this is 6 right here, and we went up 6 from there. So that's at 12. And then down 6, well, if this is 6 in the center, then if we go down 6, we're down to 0. And then you just graph the oval that goes through those 2 points. So you would just join those 2 points in that oval shape that is an ellipse. Oops. Okay. And there you go.